All right, good morning. Again, please remember that I grade your notes and I need you to do it my way. It's basically the bottom line there. Today is the 8th. In your notes, you should always put the date and you should always have a title every day. 1/8/2020. That's why I do it every day. Graphing simple rational functions. Today we're doing a little bit of graphing today. And a lot of what we're graphing comes from some things we already know. We've talked about this before, what x is not allowed to be. And it turns out that when we know this value of what x is not allowed to be, it creates a reference for us graphically. And it's called an asymptote. And in this case, it's a vertical asymptote. And we'll talk more about that. So we want to be able to find these numbers pretty easily. So number 2, what is x not allowed to be? 5 or -5? -5. X is not allowed to be -5 because -5 plus 5 would give me a 0 in the denominator, and we're not allowed to have that. This one's a little different. What do we have to do to figure out what x is not allowed to be here? Not so easy. So for this one, because we have a number in front, we can actually solve an equation. 3x plus 5. That whole denominator is not allowed to be 0. And that's really what we've done for each of these. We just can shortcut it. It's easy to shortcut it. But we're doing the same thing. We're solving a little equation because we don't want that denominator to be 0. How do we solve for x? Subtract 5, yep, so we're going to subtract the 5. So 3x is not allowed to be -5. And then, how do you get x by itself? Divide by 3. So we have x is not allowed to be -5/3. And so it turns out that these undefined values for x actually create for us vertical asymptotes. So all of these values are what we call vertical asymptotes. And that's what we're going to use to help us graph rational functions. And that's what we're looking at today, simple rational functions. Today, and by the way, when I write stuff down, you should be writing it down. That's your job right now, is to write down everything that I write down. Okay. Today, most of our functions today look like this. Y equals a over x minus h plus k. This is our very, very most simple rational function. Rational fractional function. Rational, you can see we have a fraction here with a over some stuff. Okay. And when it's in this really, really simple form, it's really easy to actually see a couple of asymptotes. From the denominator, just like we did here, we're actually going to get what we call the vertical asymptote, and I abbreviate it VA. Vertical asymptote always comes from that denominator, and we basically do the same thing we've done here. Our vertical asymptote in this case is x equals h, whatever that number is in the denominator there. And the nice thing about this is we also are going to have a horizontal asymptote. Horizontal for h there, abbreviate it with just an h, horizontal asymptote. Happens to be whatever this number on the outside is. Y equals k. And so just looking at how something is structured or the form of it, we can tell a lot of information. And once we have these two parts, the vertical asymptote and the horizontal asymptote, that's going to help us graph. We're going to use that, set it up, and that's going to help us to graph these very crazy looking functions. Okay. So we're going to start with this information. Let's see how that works. I skipped a little bit today. Okay. So example 1. Again, your notes should say example 1. Identify VA and HA, 2 points, and graph. You need the example there and directions. Directions tell you what you need to do, and those are also the same directions you would see on a test or something if I let you use your notes. It's important to have those. Identify the VA and HA, 2 points, and graph. All right, so we want to write down our simple form again, because the more you write it down, the better it sticks in your brain. We had y equals a over, what goes on bottom? X minus h. What's on the outside? Plus k. Very good. This is our very simple rational function form. That's definitely something you want to have like highlighted, boxed, whatever. And from this form, we can find our vertical asymptote and horizontal asymptote. Vertical V, horizontal H, vertical and horizontal asymptote. Where does the vertical asymptote come from? Denominator. Comes from the denominator. I'm going to ask that every day. Okay. And it's very simple to just look at it and say x equals h, whatever that h value is in the denominator. And what is the horizontal asymptote? Whatever that number is on the outside there, y equals k. All right. So when we sort of look at our example here, this first problem, what's taking the place of the a? 2. Yeah, the 2 is in place of the a. What's in place of the h? Sort of. A 3 looks kind of close to there. And what's in place of the k? A 1. Okay, so you see how everything lines up real nice? So we're in this great form, and we want to first start by finding our vertical asymptote and horizontal asymptote. What is our vertical asymptote? Now think back to the bell work. It's really the question, what is x not allowed to be? -3. X equals -3 is the asymptote that we're going to graph. What do we have to do to that value? Change the sign, right? Yeah, because we're actually solving the equation x plus 3 equals 0. For solving the equation, we would subtract 3 and get x equals -3. So that's where that vertical asymptote comes from, actually solving the equation. It's just that we can do it really easily in our head. Okay. Our horizontal asymptote is the equation y equals what? 1. Yeah, it's whatever that outside number is. We don't have to do anything to it. That's what it is. Okay, so what we just did is enough to get us started graphing. So go ahead and make a nice little graph on your paper. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're going to graph these lines. Now, I would recommend that you have a colored pencil out or another pen of another color because it'll really help you graph if you can see that you've got some boundary lines. These asymptotes means that we're not allowed to touch them. They're like, I like to think of them as electrified fences. And we're going to get close to them, but we're not going to cross them and we're not going to touch them because we would get killed. This is a vertical line. We're going to go to the x-axis. We're going to go to -3 right here at -3. And we draw our vertical line. I make it a dotted line because it's not really there. It's undefined. It's something that we're not allowed to touch. I'm going to graph my y equals 1 line. So I go to the y-axis, and I go to 1 on the y-axis, and I draw a horizontal line because that's the horizontal equation of a line. So there it is, y equals 1, horizontal asymptote. And again, an asymptote is something we cannot touch. So, and it's not really there. We're just using it as a guideline, all right? A boundary line. Now, we need to find 2 points in order to graph our equation. And so we're going to make a little XY chart. Because anytime you want to graph, all you need are ordered pairs. Values for X and some values for Y. Now, we want to choose some very, very nice values to make it as easy as we can. And so to choose some values for X, we're going to look to our vertical asymptote right here at -3 on the X-axis. I want to choose an X value to the left and an X value to the right of that vertical asymptote. So what X value is to the left of -3? -4, yeah, right here, -4. That's a great value to use. So we're going to use that as one of our X values. What's an X value to the right of -3? -2 is another great value to plug in. Those are the easiest ones to choose. Now, technically, I could have chosen lots of other points. Another X value would be -5 or -6 or -7. Or I could have used -1 or 0 or 1 or 2 or 3. But the ones closest to the asymptote are the best. Now what I'm going to do is take this X value and plug it into my function so I can figure out the corresponding Y. So I'm going to take this -4 and plug it in place of the X there. So we have 2 over, and you should write all this down, -4 plus 3 plus 1. You see what I did? I just replaced my X value with -4, but everything else is the same. And now we just need to evaluate, which maybe you can do in your head. But in your notes, you're going to write every step down so that you have something to reference. What is -4 plus 3? -1. So that gives me 2 over -1. What's 2 over -1? -2. What's -2 plus 1? -1. So we have the ordered pair, -4, -1, that we're going to plot on our graph. -4, -1 is right here. I'm going to label it, -4, -1. And now this is, I think, the hardest part about getting started here is how to draw this graph. The shape of a rational fractional function, the shape is called a hyperbola. It kind of looks like a parabola, but it's not a parabola. They're more like L's. I would call them soft L shapes. And what we're going to do is we're going to run our graph along these boundary lines, which you can see make an L shape. Well, we have to mimic that shape, but it's a soft shape. It's not as, doesn't have any square corners. It just gets close to that L shape. We run along the electrified fence, okay? That's a hyperbola, a soft L sort of shape, okay? No square corners or anything like that, all right? Now we need to figure out what happens when we plug in -2 for X. So I have 2 over -2 plus 3 plus the 1. What is -2 plus 3? 1. So 2 over 1 plus 1. What's 2 over 1? 2. 2 plus 1 is 3. So we have an ordered pair, -2, 3 that we're going to graph. -2, 1, 2, 3, right there. I'm going to label it -2, 3. And again, you see our boundary lines here, our electrified fences in this L shape. Well, we want to mimic that shape, and it's just a nice soft L. Nice and rounded corner there. Those are hyperbolas. All right. You'll notice how they're sort of opposite one another. They should, all of these today should look like that. So if yours are on the same side, then you did something wrong. They should always be sort of opposite one another. Okay? All right, let's try another. Y equals -1 over x minus 4 minus 2. The first thing we want to find is our vertical asymptote and horizontal asymptote. Where does the vertical asymptote come from? What is the vertical asymptote? Vertical asymptote comes from the denominator right there. X minus 4 equals 0. We're just solving for x. What do we get when we solve for x? X equals 4. That's our vertical asymptote. X equals 4. What gives us the horizontal asymptote? That whatever's on the outside there, that y equals -2, that outside number there. Really easy. Easy to do. We're going to go ahead and start by graphing those. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, x equals 4 says go to the x-axis. 1, 2, 3, 4 spaces. What kind of line is that? And ladies and gentlemen, you notice I'm not just writing 4. If you wrote 4, you're wrong. It is x equals 4. Has to be there because that's the equation of a vertical line. 4 has no meaning. X equals 4 is an equation of a line, and it's that vertical line through 4 on the x-axis, right? Y equals -2. We go to -2 on the y-axis. This is our horizontal asymptote. And so now you can see we've got our boundary lines set up. And again, having another color to do that in today is going to be really helpful. Gives you some guidelines to work with. And now we need our little XY chart. To figure out what numbers to use for X, I want to go to my vertical asymptote here, my vertical line. And I want a number to the left and a number to the right. What's to the left? 3. Yeah, 3 is to the left. So that's a great number to use. What's to the right? 5. That's a great number to use. All right, something to the left and something to the right of that vertical asymptote. And now what do we do with those numbers? Plug them in. Yeah, that's what functions are for. We just get to plug them in. All right, so I'm going to plug it into my function -1 over, in place of the x, we're plugging in a 3. Everything else is the same. And now we just have to simplify. What is 3 minus 4? -1. Oh, that's right. Okay. What's -1 over -1? 1. And 1 minus 2? -1. So we have the ordered pair 3, -1. 3, -1 is right here. I'm going to label it 3, -1. And again, you can see our boundary line L here. We just need that rounded off because we can't have any square. We're just going to run right along that L shape, rounding out the corner. We used to have to run the fences at my middle school back in California. So we had an upper field that was really giant at the top of a mountain. And we had to run the fences. And that's what you did, right? You didn't go straight to the corner, touch the corner, and then go up, right? You sort of round the corners. That's what you do when you run the fences. Okay, let's plug in the 5. So negative 1 over 5 minus 4 minus 2. Gotta do the 5 minus 4. 5 minus 4 is 1. So we have negative 1 over 1 minus 2. Negative 1 divided by 1 is negative 1. Minus 2 is negative 3. So we have the ordered pair 5, negative 3. 5, negative 1, negative 2, negative 3. Right here, I'm going to label it 5, negative 3. And again, you see your L shape. We need to mimic that L shape. Just round it off at the corners. You cannot cross and you cannot touch those dotted lines. You're rounding the corners. Okay? Do you have questions on these two? Is this easy or hard? It's not bad, right? It's just fine. Okay. How about one more? Last one. Why is this one different? There's a number in front of the X here. That's the only difference. Everything else is the same. So we have y equals 2 over 3x plus 2 minus 1. And the first thing we want to do is find our vertical asymptote and horizontal asymptote. Where does the vertical asymptote come from? The denominator comes from the denominator. 3x plus 2 equals 0. Solve for x. What do we do? Subtract the 2, so we have 3x equals negative 2, and then divide by 3. So we get x equals negative 2 divided by 3, negative 2/3. X equals negative 2/3. Yes, you can have an asymptote. That's a fraction. It's totally fine. What's the horizontal asymptote? Y equals what? Negative 1. Good. I really don't like answering my own questions, guys. All right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. Again, having that other color is going to be really helpful here. X equals negative 2/3. Negative 2/3 is, let's see, not quite negative 1. It's about right here. There is negative 2/3. Negative 0.6666, if you will. And we can draw a little vertical line through there. That's fine. And then y equals negative 1. Negative 1 is right here, negative 1. And we're going to draw a horizontal line because it's the horizontal asymptote. And now a little XY chart. What are some values we can use for x? You could use negative 2. Can we use negative 1? Yeah, you totally could. I think I do want to just go ahead and try negative 2. I like that. I think it's going to work nicer. All right, and then what's another value we could plug in for x? 0, yeah, 0 is a great number to plug in. You could totally plug in 0. It really doesn't matter what x value you use. It's just some are going to be nice and some aren't going to be very nice. Some will give you fractional answers and some will give you nice numbers. Okay. What do we do with this 2? Or negative 2, rather? Plug it in. Plug it in for x right there. So we have 2 over 3 times negative 2 plus 2 minus 1. Plugging in place of the x. Let's figure out this denominator. What's 3 times negative 2? Negative 6 plus 2? Negative 4. So we have 2 over negative 4 minus the 1. What's 2 over negative 4? Negative 1/2? What's negative half minus 1? How do you combine fractions? 1 over 1, you can do that. Turn it into a fraction. What do you need to add or subtract fractions? Common denominator, sure. So I have negative 1/2 minus 2/2. What's negative 1/2 minus 2/2? Negative 3/2, or negative 1 1/2. All right, so I have negative 2 and negative 1 1/2. This is about right here. Negative 2, negative 3/2. And again, this is stuff you could put in your calculator. All right, you're just simplifying. Again, we have our L shape that we're bounded by, and we just need to run the fences. Run those boundary lines. Let's see what happens when I plug in a 0. Again, plugging in 0 for x, 2 over 3 times 0 plus 2 minus 1. What's 3 times 0? 0 plus 2? 2. So we get 2 over 2 minus 1. What's 2 over 2? 1. Minus 1? 0. So we have the order pair 0, 0. 0, 0. That's a great point on a graph. And again, we have our boundary lines that we're bounded by. And now we just need to run the fences. Can't cross those. All right, ladies and gentlemen. All right, ladies and gentlemen, this is class practice number 3. Class practice 3. Don't forget to put your name and number on there. On this first problem, y equals 1 over x. What's the h? 0. There's nothing there. What's the k? 0. There's nothing there. When there's no number there, it's a 0. Okay? What's our vertical asymptote? X equals 0. What's our horizontal asymptote? Y equals 0. Very good. You want to graph those. And again, I recommend using another color. X equals 0 and a vertical line through it is just that y-axis. That is the equation of the y-axis. Y equals 0 is 0 on the y-axis and a horizontal line through it. Now, what numbers can we use for x? Negative 1 and positive 1. Negative 1 is to the left, positive 1 is to the right. And we just get to plug it in to our function there, 1 over, plugging in a negative 1 for the x. What's 1 over negative 1? Negative 1. So we have negative 1 on our graph. And again, I get to just run the fences.